Hello student, welcome to the third unit Digital Memories and Logic Families of the course Analog and Digital Electronics. Here I am Mr. C.R. Sindhe from the Electrical Engineering Department of Madhusri College of Engineering and Research Center, Nasik. Unit 3, under the title of this Digital Memories and Logic Family, uh, as per according these titles, so this third unit is parted in two sections. First sections digital memories, and in the latter sections it's a logic families. In this digital memories we studied the SRAM, DRAM, ROM and EPROM, and in case of the digital logic families we've seen PAL, PLA, CPLD and FPGA. Okay, so during this upcoming models we have to cover this all the digital memories and digital logic families. In this first model of the third unit, we mainly cover the RAM memories, that is the SRAM and DRAM memory. In this first model contains the introductions, and then we move to the basic difference between this SRAM and DRAM, and then we move to the constructions of this SRAM, DRAM and working principle, and finally we studied the applications of this SRAM and DRAM. So this is the specification of computer systems. If we go to the shops and if we want to buy a computer systems or any electronic systems, so this type of the specifications we have to already cover. Okay, so in this specifications, the one of the fourth specification is the memory. That is the important. And another one is the specification is the CD drive. This is again a ROM drive, so it's also a one type of memory. So what is the memory? What is the function of memory? What is the RAM? What is the ROM? So we have to see during this module. So what is the memory? So memory is the locations where the data can be stored, instructions can be stored, programs, coding bits can be stored. So that locations we call it as the memory. As we have to already study in the first chapter, the data is available in the form of analog, and then we convert it into a digital forms. So that digital data we stored at particular location, so that location we call it as the memory. Similarly for the instructions, programming containing a lot of the instructions words is there, so that instructional words we stored at that particular locations called as memory. Programming, if we use computer systems or our smartphones, and if we install that apps or during that functionality of apps, each and every functions is carried out only and only because of the programming. Means every functions there is a programmings behind that functions, so that programming of that apps, the programming of that particular functions can be stored in a safest location of the system is nothing but the memory. So in shortly we giving official definition, that is the portion of a system for storing the binary data, instructions and programs in large quantities, that is nothing but storage and memory. In another word, if we use the definitions, is like that it consists of the array of elements, means it's an array of latches, or we call it as the array of capacitors. As we have to already study, the latches is ability to store a 1-bit data. Similarly, capacitor is capability to store analog signal which is in the form of the voltage. Okay, so we directly told that the capacitor can store the voltage, and that voltage is in the analog forms, and then we can convert into a digital forms. So indirectly it's a storage. So this is the another definitions, it's the array of latches or the array of capacitors. For memory address, for memory locations, number of the bits is required. So in order to store the more than 1 bit, So we use the resistors. So the third point, it's given here, it's a made up of the resistor. So memory is made up of resistors, and we have to already study the resistor is nothing but the combination of flip-flops, combination of logic gates. Okay, so each and every flip-flop having a capacity to store a single bit, and if we combine the number of flip-flops, so the more than one bit can be stored, and at more than one bit it's giving a particular address, because we want to store the binary data instructions as well as programming, but in large quantity. So that's why a single bit is not sufficient nowadays. So the memory is made of the registers, which is combination of flip-flops. Now let's move to the classification. What types of the memory is available with us? Okay, so memory is firstly broadly classified into these four types. First one is the register, as we have already studied, because register is the combination of flip-flops, and each flip-flops having their own capacity to store the number of bits. So that's why register is one form of memory. Second one is the primary memory. Third one is the cache memory and secondary memory. Okay, so secondary memory we have to already use in our own days, like a CD, floppy, DVD, like that. But this primary memory is classified as a read-write memory, read-only memory. So read-write memory we are again further classified as a random access memory and sequential access memory. During this module, we are mainly concentrating on this RAM, that is the random access memory, which is belonging to the read-write memory of the primary memory. Okay, so this random access memory having two types. It's a static random access memory and dynamic random access memory. So these two type of RAM memory we studied in this module. This read-only memory is further classified as the mass read-only memory. It's a PROM, that is the programmable read-only memory. EPROM, that is the erasable programmable read-only memory. EEPROM, that is the electrically erasable programmable read-only memory. And finally, it's a flash ROM. Okay, so in this way, these five classifications for this ROM, we have to cover this ROM in second module. Secondary memory is classified as a serial access, semi-random access. So this serial access is classified as the magnetic type, charge coupled type (CCD) or ferrite core related. And semi-random access is the direct access, nothing but it's a disk, it's a CD, HD or DVD or floppy. So this is the old kind of the memory we have to utilize as a secondary memory. So this is all about the classifications. We are mainly concentrating on the RAM and ROM during this unit. Now let's move to the classification of this. Now let's move to the differentiation between this SRAM and DRAM. This SRAM, if we classify it according to uses, so SRAM is used as a cache memory, and whereas the DRAM is used as a main memory in the system. Why? Because of the speed. The speed of the static random access memory is very fast as compared to the DRAM. But DRAM is giving here a fast. Means the DRAM speed is the fast, storing, reading, writing speed, operation speed, their working speed is fast. But if we compare the DRAM with SRAM, it's slow. So that's why the differentiation between the SRAM and DRAM is like that, very fast and only fast. If we compare as per according to cost, so SRAM is the costly as per compared to the DRAM. So DRAM is the cheaper than SRAM. Okay, why SRAM is costly, why DRAM is cheaper? So we have to see in upcoming slides. Density. The density is nothing but number of memory cells per unit area. Means how many number of unit memory cells we have to utilize per unit area, that is the density. The density of the SRAM is low because the very less number of cells is adjusted in per unit large area, so that's why the density becomes to be low. Whereas in case DRAM, the density is very high. Okay. So this is the aspect from which We have to differentiate between the SRAM and DRAM. Okay, so now move to the working of the SRAM. This is the MOS static RAM cells. Firstly, we studied the constructions of this RAM. So this SRAM consists of a 6 MOSFET T1, T2, T3, T4, T5 and T6. Out of that 6 transistor, the 2 transistor T1 and T3 are cross coupled emitters. There is 2 types of data line and complement of data lines. Data in input terminals, and from this data out we can reading the data. Again, it's having a 2 select line. One is the select line Y and another one is the select line X. T2 and T4, these two transistor is behave as a load resistance for the T1 and T3 transistor, whereas the X and Y select line is used for addressing the cell. When high signal is applied on the X as well as the Y, that times the cell is selected, and when the X is high, the MOSFET T5 and T6, these two MOSFET is activated and the memory cell is connected to the data complement line as well as the data line. When Y is equals to the 1, means if high signal is applied on this Y select line, then MOSFET T7 and T8 is activated and hence writing and reading operations can be performed. So if we make the write input, this write input high, that time writing operations can be performed. If you make this write input high, that times reading operations can be performed. Means the working of SRAM is divided into 2 types. First one is write operations and secondly it's a reading operation. So firstly we studied the write operation, how the data is available in this data in is stored into this memory cell. So in order to write operations, we are making the write input high. Likewise, if we high input is applied on this W, so transistor T1 is activated, and if the data in signal is high or equal to 1, logic 1, then the point D is becomes to be a 1. And if the point D is becomes to be a 1, that makes the transistor T3 activated and the data can be stored in this memory cell. Whereas the transistor T1 is deactivated because this D is 1, so that's why the D complements this point is becomes to be 0, which makes the T1 transistor as a switch off, which makes the T1 transistor as a off condition. So in this way the data can be stored. We call it as the write operations. Now if you want to read that stored data in this memory cell, then we applied a high input signals on this write pin, and this will make the T10 MOSFET activated, and which will connect the data line complement bar to this memory cell, and thus the complement of the stored data is read, and that can be read by these systems from this data complement out terminals. So in this way, simply, so data can be write in this memory cell, and simply we have to apply a high input signal on this read pin, so that data can be read by the system. Now let's move to the DRAM. It's a DRAM circuits. Construction of DRAM is very simple. Only the MOSFET switch, which are back to back connected to the storage capacitor. So only 2 devices is used, MOSFET and storage capacitor. The another one is nothing but a control signal column side. It's a control signal from the row side. So the column signal and row signal. Whenever this column and row signal both are high, that times the MOSFET is act as a close switch and hence the capacitor start charging. So the storage of logical 1 bit can be stored. Nothing but the right operations can be done. And if you want to read, so the 0 column signal and 0 row signal, if we apply it, that times the MOSFET is act as open, and that times this storage capacitor start retaining the charges, and hence the logic 1 can be stored is read by the system. So in this way, simply writing and reading operations can be done on this DRAM simply by charging the capacitor and discharging the capacitor. The advantage of this DRAM is that only a single bit dynamic RAM it's formed using only two components. One is the MOSFET and another is the storage. So that's why the cost is low as compared to this RAM. And hence it also needs a very small area as compared to the SRAM because only the two component is utilized. So that's why the density of this DRAM is high as compared to the okay. Also the cost is cheaper compared to the SRAM. Only the disadvantage of this DRAM is the charge held by this capacitor need to refresh after the every few milliseconds, and hence along with the DRAM cell we have to use additional circuitry for refreshing this charge, and this is the main disadvantages of this DRAM. In case of applications, both SRAM and DRAM is the volatile memory. What is the meaning of volatile memory? If the information stored in the memory chip is lost when the electrical power is switched off, then the memory is called as volatile memory, and the both RAM memory is the volatile memory. Means it's retain the data only till the device is powered on. Otherwise, it's thrown the data. Okay, so all the RAMs store the informations as long as the power is on. So that's why the application for this both SRAM and DRAM for storing the data temporarily, means whenever until up to the power is on, the data can be stored. If the power is lost, the data can be lost. So this is the applications summary of this first module. We have to study what is the memory, then we studied the classification of memories. We also differentiate between the static RAM and dynamic RAM. Then we studied how the static RAM perform read and write operations as well as how the dynamic RAM perform read and write operations. We see the advantages and disadvantages in comparative mode, and finally we see where we use this RAM. Whenever there is a temporary storage of memory is required, that times we use this SRAM or DRAM. So the drawback of this RAM, temporary storage of memory, is overcome by another memory, and that memory we call it as the ROM memory. So in next module we studied the ROM memories. Thank you for watching this video. If you have any queries, so ask me any on this gmail.com or my personal WhatsApp.